This is Mark's Tech Talk, and we're going to be discussing a couple of digital devices called multiplexers and demultiplexers. So we'll examine exactly what they do and kind of how they work. So first of all, a multiplexer is a device that has several data lines. The data lines will be inputs to the device, and they are routed onto a single line. Multiplexer is sometimes referred to as a MUX. I think you can kind of call that a slang representation. Proper word multiplex, slang would be MUX. Often used slang, by the way. One output, several data inputs, and you have data select inputs. So let's see how that kind of works. Here is the pin configuration. The S inputs are the data select inputs. The D's are the data inputs, and the Y is the output. So how does this work? Well, essentially, you can think of this as having a switch inside. The select determines the position of the switch. So for this illustration, the position is set to D1. So whatever information, whatever data is on D1 gets routed to the output. You can change the position of the switch by changing the data on the select inputs. So for example, if you put a 0, 0 on the select inputs, then the switch would be switched to position 0. If you put a 0, 1 on the inputs, that is a binary 1, so the D1 input would get routed to the output. And if you put a 1, 0 there, that's binary 2, the D2 gets routed to the output. And then a 1, 1, of course, is a 3, so the D3 gets routed to the output. Keep in mind that this switch is entirely electronic. I showed you a mechanical switch just to allow you to visualize how it operates, but the switch itself is electronic. So what will happen is the position of the switch can be changed very, very rapidly by simply changing the data on the select inputs. Here is a different version of a MUX. This is an 8-input MUX. So in order to have 8 positions of the switch and to be able to designate them, we have to have 3 binary bits. So for example, a 0, 1, 0 would be a binary 2, and so the D2 gets routed to the output. So again, whatever the binary number is placed on the select inputs, that would be the position of the switch. That would in turn get routed to the output. Here is an actual pinout of a 74151. Again, this is an 8-input. A couple things to note here. The chip that you purchase actually has 2 outputs, a Y and a not Y. The not Y is the complemented output. So essentially all they do is they built in an inverter in the chip. So that if you need an inverter, you just utilize that pin. If you don't need the inverter, don't use that pin. They just had some extra real estate on chip, so gave you that option of going either way in terms of the output. This also has an enable input, active low enable input that basically turns the device on and off. So the 153 is a 4-input data selector, and there's 1 output for each one. So that's one variation of this. A 151 is an 8-input. So again, there'll be 3 select inputs. And the enable is active low and has the 2 outputs like we saw, both the regular and the complemented. Here is a picture of an actual 151, a 74151. And it's probably the only one I'll show you because pretty much all the integrated circuits look identical from the outside. The only thing different is the number on them to designate how they're manufactured, what's on the inside. But from the outside, the only difference you might see is the number of pins may vary a little bit. Most of your chips are either 14 or 16 pins, but there are some other variations, some 8 pins, there's some 20 pins, there's other variations, but these are very, very common, at least in what we call the TTL line, transistor logic. Here's a 74150. This is a 16 input, And for 16 inputs, we have 4 select inputs. So obviously this is going to have more pins on the chip. And they apparently ran out of pins on this one, so they only have a single output. There is no inverter. That turns out to be an issue with a lot of these chips. The limiting factor is not the complexity of the chip, it's how many pins are available. A demultiplexer, also referred to as a demux, is essentially the reverse of the multiplexer. This has a single data line input, and that is routed to several outputs. So this is the pin configuration. You see the data input, and you see, in this case, 4 data line outputs. And again, it's just the reverse of the mux, so the switch position is opposite. One goes to the wiper of the switch, and then you select what output you want that routed to. And again, a reminder, this switch is actually electronic and can be switched very, very rapidly. So that should give you some insight into multiplexers and demultiplexers. With that, I hope you enjoyed this edition of Mark's Tech Talk. Stay tuned for more.